Hello students, moving on to the next problems of linear transformation. So we had seen the cyclic shift. Here the problem given is one of the right shift. So we are just shifting these variables x1, x2, x3 right side, and one in the space that is left out we can tag it with 0. Similarly, you can even check for the left shift, find also the left shift matrix B, which converts this r raised to 4 to r raised to 3. So here you have the transformation, that is x1, x2, x3, x4 is shifted left side. So you are left out with x1 goes off and you have x2, x3 and x4. So here you are padding it with 0 and here you are removing the elements because second position takes the first position. So your x1 goes off and here the x1 goes to position x2. So x1 position you are padding it with 0 and here one more position is being included. So here and also you have to find the product A into B and B into A. Just write the basis of the vector. So you know that T transformation T transform x1, x2, x2, 3 in this form. So it is from r raised to 3 to r raised to 4. So you can write ax, that is ax is b. After transforming you get 0, x1, x2, x3 and so r raised to 3 given is x1, x2, x3. So depending on that you can write the matrix. So here if x1, if I take x1, x2, x3 as 1, 0, 0, 0, 0, 0, 1, 0 and 0, 0, 1, that is representing x1 as 1, 0, 0. This becomes your 1, 0, 0 in terms of vectors and this is represented as, that is a common basis vector 0, 1, 0 and here 0, 0, 1. If I take this as an identity matrix, so this becomes what here, A becomes what? For the first row, you can see here 0. Second row is x1, that is written 1, 0, 0. So x2 is your second, that is A 1, 0, and x3, that is 0, 0, 1. Okay, you can see all the three in rows, or you can say even here AX, this is your AX1, AX2, and AX3. So matrix A has been, that is right shift has been generated. So you have again similarly you can go for the left shift also. So this is if I multiply you are getting the same left shift x1, x2, x3 is shifted to 0, x1, x2, x3. So you are getting that and next this one if you multiply you are getting that right shift. Now going on to the left shift you are having what? So x1, x2, x3, x4 has to be converted to x2, x3, x4 by eliminating the first element. So here the input is in terms of, this is your input r raised to 4. After transforming this it becomes, so 3 vectors I have, the space is r raised to 3. So m is your 3 and n is your 4, m cross 3 cross 4. So you can write, I am representing the matrix with B instead of A because A already has been denoted. So what is your Bx? Bx is, this is after transformation x2, x3, x4 and what is your input x1, x2, x3 and x4. So what will be the this one? Depending on that one itself I can write the expression for the matrix B. So B, that is B into x1 is transformed into what? X2. So I have written x2. Okay. The x2 is as a normal basis vector 4 variables. So x2 comes in the position of 1 here. And next B into x2 is converted to what? x3. So you can see here x3. And B into x3 is converted to what? x4. So you can see here x4 and B into x4 is converted to what? It is converted to 0. That means you do, if you don't write that, it will have only x2, x3, x4. If you write it as 0, 0, 0, then it becomes one more variable that it becomes, that takes the form of 0 like this. So I am not writing that fourth column. So I have only m equals to 3 and m equals to 4, that you can see here. Yes. So moving on to the next problem, next what was the question? So product of A into B, you can see what is A into B, you are getting an identity matrix. Here you are getting an identity matrix. So The first vectors are 0, first entries of all the vectors are zeros. And what happens to B into A, that also you can check. Just multiply and check. This is just an identity matrix. So just write in this one. So this is your x1, x2, x3 format, and there you have 0, x1, x2, x3 format. So that is your problem. Next, moving on to the next problem. A linear transformation must leave zero vector. So you have zero vector that has to be zero itself. And what else is asked? This is zero, and this we have to prove from this. We have to prove from this P of V plus W equals P of V plus P of W. That is transformation applied separately. By choosing W equals to what you will be getting this, and prove it also from the requirement that P of CV equals to C into P of V by choosing C. So what is that? We must leave zero vector fixed. This is fixed, and prove from that is P of U P of V plus W, and even P of C into V. So we can do that by choosing W equals to minus V. If I want to prove, if I prove W equals to minus V, automatically what happens? This becomes 0, and here the transformation of V and minus V, what happens? I can take this minus 1 as outside, so you have that from P of V plus W, and you get the P of 0 equals to 0. So similarly, you can prove it next. So what is the value of W? It should be minus V. Then only you can get a zero transformation of 0 as 0. And when constant, if you choose the constant C equals to 0, then only you will be getting C equals to 0, then only you will get P of 0 equals to 0. If you take C other than 0, you won't be able to prove this equation, right? So that is easiest. And just here you have to find out the following transformation are linear or not linear. This is simple, just go through the notes, you will understand. So you have P of V equals to V2 V1. So what will be this? You are transposing. V will be V1 V2 as usual, and you are having V2 V1. So just do that position. So if I take alpha x plus beta y, x1 x2, so according to the transformation, that is alpha x dy, so alpha x1 x2 beta y1 y2. What will be the transformation? General transformation. Just I'll add those two, and according to this transformation, what happens? V2 becomes your V1, and V1 becomes your V2. That I have applied here. You can see the X2 and X1. I have applied transposition. T has been removed here. So you just check what is done. This is equal to alpha. I can write this expression in terms of alpha X2 and alpha Y2. So this is proved. So they are linear. They satisfy linearity. So similarly, check for the other vectors also. So here you have V equals to V1, V1. So V2 has been transferred to V1 itself. So I have taken X and Y2 vectors. So I can represent X1, X2. Their coefficient is alpha, and Y1, Y2, beta. So I have just expanded. Here see V1, V1. Transposition is V1.